All right, so let's go ahead and go over the fall exam review. Remember, you can pause this recording at any time so that you can slow down and make sure you understand it, and also make sure you reach out to your teachers if you have any questions. Let's go ahead and get started. So number one, the table shows the portion of a day 4 students used to build a website. Which list shows the students in order from the greatest amount of time used to the least amount? So we're looking for biggest to smallest here. So remember, when you have percents and fractions and stuff like that, you want to change them all to the same form. In this case, it might be easiest to change them all to decimals. So if we look at Jamail here, we're going to change a percent to a decimal. Remember, when we have a percent to a decimal, so let's write it out here, we're going to be moving the decimal to the left twice. So on this one, we're going to move it over to the left twice. So it'll be 0.294. So that's Jamail, 0.294. Same thing for Andrew. So Andrew is going to be 0.376 because we need to move the decimal to the left twice. Ernesto, we need to find an equivalent fraction over 100 because then we can change it to a decimal. So Ernesto, we'll do over here. So an equivalent fraction over 100 will be times 4. Oh, no, I'm sorry, 25. So let's get that fixed here. So Ernesto is 7 over 25. So we're going to be multiplying from left to right times 4 to find an equal fraction. So times 4. 7 times 4 is 28. And now we can write that as a decimal. And we're going to say it as 28 hundredths. So that equals 0.28. 28 hundredths. Remember the place value. So 0.28. And then finally, Blake is 3/10. That's already written to where we can write as a decimal. Because 3/10, remember from 5th grade, our place value. So that's 3/10. Now we're going to go ahead and order them from biggest to smallest, looking at the tenths place first. So if we were to look at the tenths place first, the 3 would be the biggest. And if it'll help you, you can write zeros at the end to kind of help you see it all in the same form. So we got 294 thousands, 376 thousands, 280 thousands, and 300 thousands. So if this will help you, by all means, go ahead and do that. So it looks like Andrew's first, or he's the biggest. Then it looks like Blake is the second biggest. And then 294 is bigger than 280. So we're going to do Jamail as third, and then Ernesto is fourth. So let's go ahead and take a look at our answers. Should be Andrew, Blake, then Jamail, and then Ernesto. So the answer will be A. A. It says here, which list shows the numbers in order from least value to greatest value? So now we're going from smallest to greatest. Once again, we're going to need to change all of these to decimals, but at least they're all the same numbers. So we already know which one's going to be the biggest. It's probably going to be, we already know 5 is bigger than those negative numbers. So it should be negative to positive. 5, well, it may not be the biggest though. So let's go ahead and figure out. So negative 2/5, we'll start with negative 2/5. And that we're going to try to set into 10. 10 should be easy. So times 2 here. So negative 4/10. So negative 4/10. And then we need to change, we already got negative 2.47, so that's done for us. Negative 2.5, that's a benchmark fraction. So negative 2.5, half, remember, is 0.5. So that'd be negative 2.5. Then we have 5. 5 is kind of obvious. And then we have 21/4. 21/4, if we were to make that into 100 and do the hundredths place, we wouldn't be able to do that. Because 4 times 25. So times 25. Actually, let's just divide it. Dividing it will be easier because it would be a whole number anyways. So 21 divided by 4. Remember, fraction is division. So 21/4, we're going to divide that. So 21 divided by 4. Remember, the guy on top falls through the roof, kicks the 4 outside, or you can also think of 21 as a diving board, diving into the pool, and that would be the side of the pool, so 4 would be on the outside of the pool. So let's go ahead and divide this. We already know it's going to be a decimal. So we've got 20, 10 here, so 2. We already know just by looking at it that's going to be bigger than 5. So let's just finish it out. So 5.25. So 21/4 is going to be 5.25. So we've got negative 0.4, negative 2.47, negative 2.5, 5, and 5.25. So the smallest or the biggest negative, remember the biggest negative is actually the smallest value. So it'd be negative 2.5 or negative 2.5. So this right here is going to be our smallest. So that's going to go first. The negative 2.47 is right below that. So that'll be second. It looks like negative 0.4 is going to be third. Third smallest, because we're going least to greatest. Our fourth smallest will be 5. And then finally, our 5.25 will be our fifth smallest. So now we can write them from least to greatest. So we got negative 2.5 should go first, or negative 2.5. So it looks like these two are wrong here. Negative 2.47, so these two are right still. So we already know B is wrong and A is wrong. Then negative 0.4 or negative 2/5. Negative 2/5 is third. It looks like those are the same still. And then 5 would be fourth. And then 21/4. So our answer is C. Our answer is C. All right, which pair of numbers are equivalent? So which ones are equal? So here we got 0.75. That's less than 1. 75 over 10 is bigger than 1. That's actually going to be equal to 7.5 if you want to divide it out. So we know these two are not the same. 0.8 and 8%. Remember, if we were to find 8% as a decimal, we would be moving it to the left twice. So it would actually be 0.08. So not 0.8, it would be 0.08. So that one's wrong. Then we have 0.4 and 1/4. 1/4 is a benchmark fraction. That's actually 0.25. So it's not C. And then finally 0.03 and 3%. Let's go ahead and show you 3%. Since it doesn't have a decimal, we need to put it there. And then we're going to remember move the decimal to the left twice. So it'll be 0.03. And those look like they are the same. So there you go. D is your final answer. All right, a teacher wrote this expression on the board. What is the value of this expression? So in this problem here, remember you want to do the parentheses first. And then, so basically you're following the order of operation. So parentheses first. So negative 8 divided by 4. Remember, a negative divided by a positive is a negative answer. So I'm going to rewrite it here. So I got negative 6. Remember, parentheses mean to multiply. Plus a negative 2. So that right there, negative 8 divided by negative 8 divided by 4 is negative 2. Now we need to multiply because that's next in our order of operations. So negative 6 times 2. A negative times a positive is a negative answer. So this right here is negative 12. And then finally we have negative 12 plus negative 2. As you can see, we're adding, so we're in good shape. We have the same signs. So we're going to add 12 plus 2, and then we're going to keep the sign. So it's going to, our final answer is going to be negative. So 12 plus 2, which is 14, and then we keep the negative sign because the signs are the same. So our final answer is negative 14. Negative 14. All right, so what is the value of 3/7 divided by 9 over 21? So remember, you can't really divide fractions. So we're going to try to change it to a multiplication and then go from there. So 3/7 divided by 9 over 21. We're going to rewrite this, and we're going to keep the 3/7. We're going to change the the division to positive, and then we're going to multiply it by the reciprocal. So it's going to be 21 over 9. So remember, reciprocal means you flip the numerator and the denominator. So here we have 3/7 times 21 over 9. You can multiply it out if you want, but I would cross-simplify to make this easier. So I'll go ahead and multiply it out just in case your teacher hasn't taught you that. So 3 times 21, which is 63, and then 7 times 9, which is 63. And as you can see, 63 over 63 is equal to 1. So 63 divided by 63 is 1. So our final answer will be 1. Awesome. Number 6, which equation is true? So we got another one where we're trying to find equivalent fraction, decimal, and percents here. It looks like just fractions and decimals. So 9/10, 90 hundredths is equal to 9/10. So it looks like those are equal. Let's prove these ones wrong. 12 over 10 is equal to 12 divided by 10. And as you can see here, 12 divided by 10 is 1.2. So 12 over 10 is equal to 1.2, so that one's wrong. 1.9 is definitely not, is greater than 900. So 900 equals 0.09, so that one's wrong. And then 18 over 9, 18 divided by 9 is 2. So 18 divided by 9. Remember, fractions are just division. So this is really 18 divided by 9, which is equal to 2, which doesn't equal 0.2. So as you can see, our answer is A. A. All right, number 7. Mrs. Torres is mailing a package that weighs 12.5 pounds. The post office charges by the ounce to mail a package. How much does the package weigh in ounces? So you would need to use your conversion chart for this one. 1 pound on your chart equals 16 ounces. So we're going to make our conversion table here. And we have pounds. And we have ounces. Our given is 1 pound is equal to 16 ounces. In our equation, it says Mrs. Torres is mailing a package that weighs 12.5 pounds. So this is going to be 12.5. And it looks like we're trying to find how many ounces that is. So you have a couple things you can do here. You could go up and down and multiply by 16. Or you can go from left to right and multiply by 12.5. Well, it looks like no matter which way you go, you're going to do 16 times 12.5. So 12.5 times 16, we get 5 times 6, which is 30. 6 times 2 is 12, plus 3 is 15. 6 times 1 plus 1 is 7. Then we have our place value holder. And we got 5 times 1, which is 5. 1 times 2, 2. And then we're going to add all those up. 7 plus 1 is 8, plus 2 is 10. And then finally, we need to add our decimal point. Remember, you look at how many place values are after the decimal point and our initial factors. And in this case, there's 1. So we're going to add 1 decimal point there. So our answer will be 200 ounces. 200 ounces. And like I said, if you're struggling with any of these, make sure you reach out to your teacher or review your notes and make sure you are understanding it before your final exam. All right, let's take a look at number 8. A grocery store clerk put only packages of flour tortillas and packages of corn tortillas on his shelf. The ratio of the number of packages of corn tortillas to the total number of packages on the shelf was 7 to 16. So corn tortillas to total is what they give us, 7 to 16. So that's 7 to 16. Which number could be the number of packages of flour tortillas the clerk put on the shelf? So we're not looking for corn tortillas, we're actually looking for flour. So we're going to need to subtract 16 minus 7 to figure out how many of those 16 packages were flour. So 16 minus 7 is 9. So our flour to total is going to be 9 to 16. And then it says which number could be the number of packages of flour tortillas that occur on the shelf. So we're looking for something that would have a ratio of 9 to 16, or something that's proportional to flour total. So if we were to multiply times 2, we would get 18 out of 32 packages. So 18 would work. None of those other ones would work. Okay? So 9 times 2 is equal to 18. So we would be able to have 18 packages. This is a very tricky problem, and you got to make sure you read it correctly. So make sure you look at that one, make sure you understand that one. Number 9. In Austin, Texas, 8 bats ate 40 grams of insects in one night. At this rate, how many grams of insects could 64 bats eat in one night? So on this one, you're going to have to set up a proportion again. So our total, so we have bats, and we have grams that they eat. 8 bats eat 40 grams. We want to know how many out of 64. So, in order to do that, we're going to need to divide 40 divided by 8, and now show us that our relationship is 5. So it's going to be, if I'm going this way, it'll be 64 divided by 5. If I go up, it would be times 5. But in this case, we want to go down. So 8 bats eat 40 grams of insects. At this rate, how many grams of insects could 64 bats eat in one night? So we're going to do 64 divided by 5, and then hopefully we get a nice, easy decimal. So 64 divided by 5. We know it's going to be a decimal, so let's go ahead and get that set up. 64 divided by 5. So 2, 10, 48. And it looks like we will have nothing left after we subtract our 40 there. So 12.8 grams of insects. At this rate, how many grams of insects? It's 60. Oh, looks like I messed up. See, even teachers make mistakes. I had this backwards. I labeled it wrong. So we have 64 bats, not 64 grams. 64 bats, not 60. I was going to say, it's a little too difficult. So let's try this again. So 8 bats to grams. Always check your work, as you can see. 8 bats, 40 grams. We have 64 bats. So it looks like to get from here to here, we're going to be multiplying by 8. We go from left to right. So we want to find an equal fraction. We want to find an equal fraction that has 64 bats. In order to do that, we have to multiply our numerator and our denominator by 8. So 40 times 8 is 4 times 8, which is 32. And then we obviously bring over the 0. So 320 grams. 320 grams. All right. That's why you always check your work. Cafeteria manager surveyed a random sample of students at a school to determine which of 2 meal choices they prefer. The results of the survey are shown below. Chicken is preferred by 30 students. Pasta is preferred by 18 students. Based on the results of the survey, how many of the 240 students at the school can be expected to prefer chicken? So we have a total of 240 students, and we want to know how many of them eat chicken. So total students, chicken students. So when we set our table up, we're going to look for how many total students we have and how many like chicken. So our given is that we're going to have to add our 2 up here. So 30 plus 18, which is 48 total. So our ratio is 48 total. So when they tell us what they surveyed there, 48 total. That's our given. And out of those 48, 30 like chicken. So that's our initial ratio. And then they tell us that it's out of 240 that they want to know how many eat chicken. So we're going to use that ratio to help us figure out how many out of 240. And as you can tell, well, maybe you can't tell, but 48 times 5 is going to be 240. But you may not be able to see that. So let's go ahead and simplify this down. And let's start with 2. So we're going to divide both of these by 2. And we're going to rename this to 15 over 24. Once you get that far down, you might be able to see that 24 can go into 240. Hopefully you can see that. If not, you just need to keep going a little further. But let's say you do see that. So 240 divided by 24 is 10. And since we're going to be going from 15 to our answer, we're going to be going from left to right. So it's 24 times 10 to go from left to right, because it's going to be getting bigger. 15 times 10 is 150. So 150 students. 150 students would eat chicken if 240 total students ate. So there you go. Makes sense? All right, let's take a look at number 11. Pretty tricky problem. The pictograph below shows the number of samples of matter being tested in an experiment. It looks like each one represents 5 samples. So that means that liquid was 25. So 25 there, since each one is 5. 4 times 5 here, so 20. And here we just have 1, so 5. The ratio of the number of gas samples to the number of liquid samples is represented by 1/10. So we're seeing which one of these is correct. Pictograph below shows the number of samples. It looks like we need to fix the question. I'll fix that here in a second. But for now, we have assuming it's basically which of these statements is true. So which of these statements is true? So the ratio of the number of gas samples to the number of liquid samples is represented by 1/10. Actually, gas is 1 to the number of liquid, which is 5. So that would be 1/5. So that would be 1/5, not 1/10. So that one's wrong. Should be 1/5. The ratio of solid samples to all the samples being tested is represented by 0.4. So solid is 4. So I'm just using the pictures right now. They may want us to do the total, but it doesn't look like they want us to use the total, so we'll be fine. But in this case, solid, well, we'll just go into 20 out of 50. So there's 50 total. So it'd be 20 out of 50, or you can just do 4 out of 10. 4 out of 10. I'm just going to do it the easier way. 4 out of 10, which we all know is 4/10. So that one looks right. The ratio of the number of liquid samples to the total number of samples is 1 to 2. That one looks right. I think I know what the question is now. The question's probably asking which of the following below is incorrect. This is correct. Liquid samples is 5. The total is 10, which is equal to 1/2, so that one's true. And then the ratio of liquid and solid samples, which is 9 over 10, 10 total, and that's 9/10, so that is true. So looks like our answer is going to be A. Our answer is going to be A.